Hello everyone, this is the Grumpy Man, and as you have noticed, today's video will be in English. There's a very good reason for it, because today I will be introducing my library called Payton, and I will do a quick introduction to that. And for that reason, I want to reach as many people as I can. I know that my English is not perfect, it's far from being perfect, but still I will give it a shot, because I just want to be heard, and I guess it's like to try every now and then, right? I guess so. Anyways, at least my English is far better than my German, which is at the level of Ich bin Sinan, and that's pretty much it, and Ich liebe dich, and at that level, so you got the idea. So, today I will be talking about Payton 3D. So, back in my career, once I was working for a company, and I don't want to mention the name, but because the company's name has already been changed. But anyways, yeah. So inside that company we had tech talks or hobby talks. We had a hobby hour, and within that hour everybody was just presenting their hobbies. It can be photography, or it can be whatever they are interested in, bikes and stuff, mountain hiking and all that kind of things. And my hobby, which still is back that time, was 3D programming. So I started my career as a 3D engineer, as a 3D programmer, working for a CAD company. So within that hour, I wanted to present my hobby as 3D programming with OpenGL. And I thought that maybe at least within an hour, because I was feeling like, okay, I know this topic, and I could introduce people to 3D programming within an hour, and boy, I couldn't be more wrong. I failed catastrophically. People were sleeping at the end of the presentation if they haven't left already. And then I realized that, okay, this stuff is quite hard to tell people in a quick time. So, because when you want to introduce someone to 3D programming, you have to talk about space geometry, you have to talk about how graphic card works, how OpenGL API works, and how to do threading, and how to set up the SDL for Windows, and how to do the keyboard controls, how to align the matrices for projection of the scene, and all that kind of stuff. And it was, well, so hard. And even if you do not use directly OpenGL, but use some middle libraries like RRLit, or I don't know, Ogre, or any other OpenScene Graph, any other 3D library, then instead of learning all these OpenGL internals, you have to start with the libraries internals, because all these libraries wants to give you all the abilities to create anything that you have in mind. They are designed to give you ability to create a CAD software, or a 3D game, or anything that you can imagine. So to give you this ability, they are still quite verbose, because you have to set up other things within those contexts. Yes, you are not directly dealing with OpenGL, and in some cases those libraries can support multiple graphics APIs like DirectX or Vulkan or others, or software renderers that they have created for their own. But still, you have to learn a lot of things, and still you cannot get started within an hour. So I wanted to change this a little bit. So I wanted to give people, but within that presentation I realized that people were eager to learn it. In the beginning, I had many spectators, and I could see that they were all eager to learn it until they realized what they have gotten into. So I took this as a challenge, and I wanted to create a platform that would give them the playground to fiddle with the 3D stuff and get started with it. If they want to, they can continue from Payton to other libraries or game engines, but at least I wanted to get their feet to the sea, to the water, and get them started with it. That was why I have created Payton. So what is Payton? Payton is an OpenGL based, modern OpenGL based Python library that you can easily install and get started with. And it comes with almost everything that you need, but it does start with quite many defaults that you can even create your initial scene, initial 3D environment, your playground, just by using 3 lines of code. Or actually, 2 lines of code is sufficient to do that. So, today I initially created the video, so I'm retaking the speech part of this video, but I will be using my initial screencast, which is, I guess, quite sufficient. So there we go. I will be narrating the video. I believe this is the initial one. So here we have the Linux environment, and I have the Visual Studio Code open. And let's go full screen, and let's start by creating a virtual environment for this tutorial, and let's call it Payton Tutorials. Payton Tuts. Okay, we have the environment. Now let's head into the environment and activate the environment. And all we have to do is to use pip install Payton, which is quite the basic command in Python to install stuff, if you are aware. And I'll just go ahead and copy paste my Python path, because I will be needing that to show Visual Studio Code the path to be used for the environment. Let's head into the projects directory and to the Payton tutorials and create a file called main.py. There we go, and it asks for the interpreter path, and I just enter the interpreter path here. Now we are ready, and let's get started. Yes, the path is correct. I can verify that. So from Payton.scene, import scene. So what's the scene? Scene is assuming that you are creating some, I don't know, a movie or something, like you have the name scene here. It's basically where your props and objects just lay. It's the place that you are making your things. In some environments this is called space or 3D space, or I don't know, it has many names, but here in Payton we have the name as scene, and scene is the base of everything. It holds your camera, it holds your objects, it holds your light, and it looks like everything happens within the scene context. So we can move forward from here, I suppose. So let's go ahead and create a base scene. I don't really have to give any window size for this, but if you want to give it some explicit window size for the initial state, you can just define them here, or you can just create an onSelect method for a callback, which I'll be talking about soon. And just base.run, and let's run this example. And there we go, we have the scene. You can just go full screen, and within the scene we have the grid, and we have the mouse controls, we have the keyboard controls already, like we can zoom in and zoom out, we have the camera controls to change the perspective mode to orthographic mode, and we even have the user interface, which when you click on H button from your keyboard, you can see that you'll be introduced to Payton shortcuts. And there we have, and if you press the escape key from the keyboard, it will just quit. Excellent. So, but still we are far from perfect. Like, is this all? No, definitely this is not all. So let's go ahead and add some cube to the scene. And to do that, let's alright, from Payton scene geometry, import cube. So go ahead and let's create our first cube here, which I did a typo. Alright, and I don't want to give any size information, so I just want a unit cube which will have 1:1 size, and let's add this cube to the base C. Yes, add object. Let's give object a name here. Let's call it cube1 and add the cube to the scene. And let's run this as is. And as you can see, we have the unit cube here. How easy it is. So we are still being like, we can still do something more here. Okay, let's go ahead and create some random cubes all around the place. And I will be needing a random library. Import random. Alright, so X position, like all of you are at least aware of the Cartesian coordinate system. So I want a random integer between -5 to 5, and for y again the same, and for z let's keep it as 0, and let's move the cube to this context and give the cube the position as x, y, z, and let's add this cube to the object, and object names should be unique. So I'll just give it dynamic name, and let's run this, and there we have the 10 good cubes. Let's count down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cubes, all in random places. Cool. Well, let's do something more. So let's go ahead and let's click on these cubes. Now, we want to select the cubes and do stuff with them, obviously, because otherwise, what can we do with the cubes? So we will have a list of objects. And let's bring the objects first. And obviously I need to move this method to the top, because scene has to be aware of this method. So on select, scene will call this callback function whenever we select an object. We run the example, and as you can see, it prints the object down at the console. Good. Okay, let's do something more, and let's try to hide the objects, the selected objects. For object, and this is a bad naming, let's change it to P object. In list of objects. And P object dot, oh crap, autocomplete didn't work. Why? Because it doesn't know the object type, and it has to be a list initially. So let's go back and fix the crappy code. It's a list of cube. So from typing, if you haven't already used the typing in Python, I highly encourage you to do that, because it comes with many helps. Especially if you check your code with MyPy, you will realize that if you are using typed code, then it will warn you about your misuses, just like the places where you push an invalid type of an object to a method or something like that, as well as it helps with the IDE to come up with the auto-completion. And in this case, our IDE VS Code is capable of realizing that we are actually working with a list of cube, and P object will be a cube in this context, so it just shows us the proper auto-completion list. Now let's run this example, and as you can see, when we click on objects, they just go hidden. How awesome it is. So Let's change this example. Let's see the geometries. So we have line and object and cube and cylinder and MD2 file from Quick, and we have the mesh, we have the particle system, matrix plane, plane. Mesh is a triangular object, by the way. So we have the particle system, matrix plane, plane, and ragdoll object, which is crappy, but I still have it, and sphere and wavefront. And there's also one additional file format that is not shown here due to circular dependencies, which is the AWP 3D format, which is animated wavefront pack format. I have created this format. It's simply a zip file with every frame of an animation as the wavefront object file. So Payton just unpacks the zip, loads the wavefronts, and puts them in an order for the frames and pushes them to the graphics card. So let's go ahead and change this example a little bit more. Let's delete this part. We've already seen it. And this part as well. Here. So let's do some animations. So base object, scene, has a feature called clock. So clocks are ticking threads. It has a name, it has a period, a ticking period, and a callback method. The way it works is it's actually a thread, but it calls your callback method in given intervals. By using these given intervals, you can ensure that your animation will run at a fixed speed. Back in the days, I was also doing the same mistake. I was making my animations within the render cycle, which was bad because if your render frames per second increases, then your animation gets faster, or if you have a crappy computer, then your animation goes slower. But even we can afford some skipping frames, but we want the animation to be completed in time, then we have to do it in a timed manner, and there we have the clocks in place. So let's go ahead and create a clock here. Let's call it a name as universal clock, and let's give it a period. This period is in number of seconds, but it's in float, and we have a callback method here. The method gets two float variables, which is for period and the total seconds passed. Yeah, there's an example at the bottom of the autocomplete. Okay, so let's give this callback a name. Let's define the callback method here, shall we? So we have the move box. We have the period and the total seconds passed, and let's say pass for now, so that we can just move it here. Okay, and let's go ahead and create a box for the scene, the default size, and let's add this box to the scene. So within my animation, I want to create a condition where in the first 2 seconds of the animation, I want box to move in X direction. So my box position is a list of numbers. So let's move it slightly on the X direction, and and let's keep it the same for the y direction, like no change and no change in z as well. And in the upcoming 5 seconds, like 3 seconds actually, from second, yeah, from the second to 5th second, we will go backwards, and when we are between the 5th second and 10th second, we will go upwards this time. And let's fix the if condition, shall we? Oh no, actually we don't have to. Like, if t is larger than 10, then let's reset the box position to origin. And also we need to, come on man, just go ahead and fix that if condition on the line 23. It annoys me now. Really? Because yeah, the next if condition will solve the issue, but still it's bugging me there. Alright, let's go ahead and run this example without fixing that third if condition. But it will work, like it's in a bug, but it would be nice to have. So when we first run this example, we see no motion. That's because we need to hit space bar to start the animation. Let's hit it. And there we go. And end of the animation here. It's that simple. Let's go ahead and import a plane, and let's create a ground for us so that we can demonstrate the shadows in Payton. By default, OpenGL cannot create shadows for you because shadows can be done in various methods and it's a costly operation indeed. In modern game engines, shadows are in modern 3D game engines, shadows are pre-calculated by some ray tracing engine and like they are burnt to the scene. Only the dynamic shadows are calculated within the game. So as you can see, we have the shadow behind the fire cube, and this is a dynamic shadow. I have this thing, like whenever I talk too much, my throat gets itchy all the time. It's not corona or something. I have it for years and I hate it. My nose starts wrong and I get this itchy because I believe I'm allergic to talking. Yeah, that's why people think I'm asocial, which might be true. Anyways, let's go ahead and animate this shit. And as you can see, we have the animated shadows as well. So here I do have my Blender screen. So I initially started my career as a 3D programmer, and Blender is one of the earliest tools that I started to use. It was not very much heard of back in those days, but nowadays I guess many people in the 3D industry knows about Blender. It's quite competitive against 3D Studio Max or Maya or Cinema 4D. It has almost all the features that you might need, and many render engines like V-Ray is now supporting Blender. And you can find quite many resources because Blender is absolutely free to use, and it's open source, and it has a very good Python engine embedded inside. So if you know Python, you can create your own add-ons within Blender, and it's pretty cool. And let's go ahead and just install our Payton add-on to Blender. So for that you will see the Payton add-on within the Payton GitHub repository. So let's check it out. So here is my GitHub profile, you can see. So just head into Payton repository, and there you'll see the Blender plugin. This plugin works from Blender 2.8. I also tested it in 2.9 and it works well. Unfortunately, and actually fortunately, Blender changed a lot of things in version 2.8, so the add-ons are not backwards compatible between 2.7 and 2.8, and I didn't waste any time to support the older versions of Blender. So we have the animated waveform package exporter for Payton. You have to download the repository in order to have this file, or you can also download that file individually, but it doesn't come with the pip package because it's not the part of the standard Payton library. So let's go ahead and install that into Blender add-ons. There we have. So on the bottom you can see it, and if it's not enabled, just go ahead and enable that. So let's go ahead and instead of creating an object, let's go ahead and get into free3d.com and find ourselves a nice looking animated object. This is one of the free 3D object websites that I occasionally use. So let's head into the animated objects, and I guess we have a nice looking dragon here by 3D Helped. Let's go ahead and download the Blender files. Let's open it with Archive Manager. And let's extract this to the desktop. So there I open it and select the object itself, not the skeleton. Go ahead to the file menu, to animation, okay, to the file, export as AWP 3D to the home directory, and let's call this dragon. There it's exporting, so fast forward. It takes a while to export the object, and we are heading back to Payton to VS Code. And let's go ahead from Payton scene geometry, import geometry.awp3d, import awp3d. And we're gonna keep the plane, but we will get rid of the box. We don't need the box anymore. And we have the dragon here, and the file path to the dragon. And we'll keep the frames per second as is, because as I mentioned, like we can adjust the frame per second from there. And it's about the speed of the animations. And let's add the dragon object to the scene. And we do not need this move helper anymore. Let's comment it out, and let's comment out the clock as well. And let's run the example, shall we? Okay, in the state, you can see that there's a loading bar below at the console. The reason for that is that it's unloading, unpacking the archive, and like pushing the archive to the buffer and like parsing it. And as it's an interpreted language, this part actually takes a while, so apologies for that. I'll try to improve the performance there, but most likely I'll have to change the file format a little bit to enable that, to a faster parsing thing. And initially, when we first load the object, you will notice that it's a little bit of lagging behind. The reason is it's actually now building all the frames to the graphics card, and when it's done, it's smooth as hell. There we have our good little dragon. It's not actually that little, so I probably have to like scale it down a little bit. Maybe, I don't know, 1/10 of its original size. I didn't really check it on Blender. I should have checked it on Blender, but it's no big deal. Like, we always have these kind of troubles. So just go ahead and let's scale the dragon.scale, and let's do it like 10% of its original size. Okay, I guess that should do. And let's run it again. And let's wait for it to get built again. By the way, if you are curious about the scale, it's actually scaling the model matrix, not the object vertices, so you can do the same operation easily and it's fast. Now it's building the frames in the graphics card, and once it's done, clears the RAM and like just runs on the graphics card after the first cycle. And there's our little dragon. How cute, isn't it? So many frames and shadow and high polygons, and it's solely on Python. That's one other good thing about Payton is like you do not have to build anything in C or C++. It just uses the standard Python. So even with a fresh installed machine, if you have Python and STL library installed, then it shall work. You do not have to install anything else. And obviously your graphics card needs to be able to run in OpenGL, like OpenGL 3.3. And if on Windows, if you encounter problem with the graphics card, or not in just Windows, but okay, let me just stop it here a little bit. So on Windows machines, or it doesn't have to be Windows, in older machines, if your graphics card doesn't really support modern OpenGL, then there's a workaround. You can still go ahead and install Mesa 3D libraries, which are actually it's still OpenGL API. It gives your computer the ability to run modern OpenGL, but the way it does that is, instead of running things on your GPU, on your graphics card, it runs the rendering on your CPU and on your RAM. So it will be lacking a lot of performance, but at least it will be good enough to run Payton. I have tested it myself on Windows 10 machine that I have in my VMware, and it works. So if you claim that it doesn't work for you, you have to figure it out. There's one tricky thing though. There's a false positive for Windows Defender on Mesa 3D Windows builds. I don't know why that happens. I hope Microsoft solved that, because there is absolutely no virus or whatsoever or inside Mesa 3D builds. I even tried to build the Mesa 3D for Windows myself, and I encountered the same error. Somehow the compiler generates some block of code for that causes Windows Defender to think it's a Trojan or something. Probably that just collides with something in their signatures. But that's the thing. So let's go ahead and check out Payton examples. Payton examples eventually has everything that you need. So let's check out a practical example. And for this example, actually, I'll just probably change the frames per second for recording the screen, because the frame rate for the screen recorder up until this time was like 10 frames per second, but for the rest of the examples that I will show, it's not enough. So I'm switching to the next recording. Okay, here we are with 60 frames per second, and we have a much smoother looking thing here. And let's hit it, and kaboom! We have lava raining down on us. So there are 10,000 particles in the scene, and their locations are calculated by a clock in the scene. Let's go further and check out the animation once again to see how big it is in reality. So this animation actually calculates the position of every particle in the scene. Let's assume that we are a real person, and like we are in the ground zero of an explosion, and it's raining lava. I hope this will always be just an animation. And we have more examples here for you to check. But first, let's check the source code of this example, and you will notice that it's only 67 lines of code, and it's written in an object-oriented approach instead of just plain base scene. We have the particle demo extended from the scene, inherited from the scene, and like we have the generate particles, and we have the animation clock callback, which calculates the position of every particle in the particle system. And here in the main, we create a particle system, assign it a color, and create the clock, etc. in one other example. So in this example, the scene will just highlight the colliding objects, and in the next example of the collision, it's animated, and there are two different algorithms to detect collision. One is a crappy but fast, the second one is a bit slower but works better. So green one is the better one, red one is the crappier one, faster one. But if you have thousands of objects within the collision detection, then it's better to use the red algorithm over green one for performance reasons. And here in the next example, I guess we can show you the spotlight example. We have a single source of light inside this conic shape, and we actually create this spotlight effect by using the conic shape we have created, and the light follows it. And we have the day example, which changes the background color based on the time of the date. So let's hit the spacebar, and while it's changing the shadows, it gets a little bit of flickering. It's an odd thing, and like I will fix it someday, but it's not that urgent to me. When you stop the animation, the flickering just vanishes. It just does that when it's changing the sun location. So in the higher level examples, we have the multiplayer example, and let me just quickly run the server first. Yeah, it doesn't work that way, idiot. And it's listening now. And let's go ahead and activate our virtual environment, and let's run the client. So in the first client, let's create several cubes here, and let's fire up another terminal window, and let's activate the environment, and let's create another client, and this connects to the server as well. And as soon as it gets connected, server pushes the latest state of the scene, and as you can see, both clients can simultaneously communicate through the server and work on the same scene. How awesome would it be if you are an architect or something like that, and you are just working on the same scene with your colleague? I believe there are already some tools from Autodesk that does that, but you can also do that in Payton. And within the mid-level examples, you'll see the ripple example, for instance, which is my favorite. I use this occasionally for benchmarking stuff. So here we have 900 individual particles, which gets just ripples. And works quite well. So as a benchmark, let's go ahead and increase these 900 particles to 30 to 30. And let's make it 100, so we'll have 10,000 points here, and it's still responsive. Yeah, it's lagging a little bit, but not bad, not bad. Assuming that this ripple is calculated on the CPU, not the GPU, so this is not a shader. It's quite fast for a shader. And here in the Payton repository, you can see quite many examples. There's always a feature for every example. There is always an example for every feature, and the examples are always to the point, like they are kept in small size so that you can understand them better. So I hope you enjoyed the video so far, and see you later.